And if you scroll down, ID2 corresponds to max and power mode, and this is the power mode that we want. Hello and welcome everyone to this part 3 of the Jetson Orin Super Developer Kit's setup process. So this is the video where we'll do the AI server setup for us. We've already done the unboxing and the first look where we saw how we purchased it, how the firmware upgrade was done, how the OS install was done using the Jetpack 6.1 and an SD card, the first boot, and unlocking the max and mode, the 25 watt mode over here. The second video, we did the install on the SSD, right, which involved doing the SDK manager install on Ubuntu 22.04, and that was pain in the butt, but that is something that we had done. And we also did the first boot with SSD over here for us. So now in this video, we'll be taking a look at the Docker that comes pre-installed with our Jetson over here, and then we'll do two things: Ollama setup and OpenWebUI setup, right? These two things we'll do. Now, something to note over here is that I already have a guide that I normally follow, my AI server setup guide that I use for my Linux servers that I build, right? So I have a 4 times NVIDIA 3090 setup, I have a 2x 3090 setup, 1x 3090 setup. Today we'll take a look at how can we adapt this guide to work with our ARM-based Tegra processor that we have in our Jetson Nano. All right, so all that being said, let's dive directly into it. All right, so step 1 for AI server setup is to have our Jetson booted up. So I've just plugged it in. I've also plugged in LAN wire over here. It's hardwired. I'm not using Wi-Fi for the purpose of having faster downloads over here. So let's switch to our command prompt over here. So I'm on a Windows machine right now, and I'm gonna SSH into my Jetson. So let's see if the Jetson is up first. My Jetson is at 192.168.115, and it is available at this host name. So SSH, my username in this SSH was in my Jetson was Mukul. Yours would be whatever you have chosen when you were installing the SSD. At that time when you pre-configured, you chose a username. That is what this username is. And then we can choose the Jetson and the password that you chose at that time. Okay, let's do a Tegra stats to quickly check different statistics of this. So we have 712 of the RAM occupied, and looks like everything else is normally up and running over here. So we are looking good over here. So I'll let it go like this. I'll do a control Z over here to get out of it. Let me pull up the guide that I have over here. So this is the AI server setup guide that I normally use for my Linux server setup. So I'll go over here. If you see in the base setup, webmin and Docker on Ubuntu, right at the very bottom, you will see that there is one command, this particular couple of commands over here, which let you run Docker without using the super user permissions over here. So for example, if you do Docker, let's see if Docker comes installed, and it does. If you do Docker run hello world, hello world, it'll say that permission denied while trying to connect Docker daemon socket and all that, right? It is saying that you need super user permissions. Do not do that. Do not do that. Then there is a very good reason for it. If you run Docker with super user permission once, then there is a particular file that gets set with the super user permissions at that time. So do not do that. Do not fall into the trap of running Docker, with super user. If you have done it, there are ways to fix it, but at this point of time, I'm just going to show you how I would do it. I would just never run Docker with SU to begin with, and I will run these two commands that I have over here to copy these one by one. So this is the first command, and paste. And then I have to copy the second command, new group Docker, to have this apply. So what we are doing is we are adding the user to this particular group over here, to the Docker group over here. And then we are having these new permissions take effect without having to reboot. So now if you do the Docker command over here, Docker run hello world. If we run this command again, you'll see that this runs now without the super user permissions, which is awesome. This is what we need and want. So the command that we want to run to install our Ollama is, where did it go? There it is. Okay. So Ollama and OpenWebUI. So you do not need to do all these NVIDIA container toolkit and all that. And all this is already preset for you, right? You see how when you have to run this on a regular x86 machine, then you'll have to configure the NVIDIA CTK and configure it with runtime Docker. And this gives Docker the permission to access your GPU. You don't need to do all that anymore, right? And there is no GPU's flag also for your Docker now. So you don't need to do none of this. What you do need to do is pass a special command which will say use the runtime of NVIDIA over here, right? So instead of saying GPUs and all that, you have to just use the runtime NVIDIA. And what I'll do is I'll copy this command over here, and then I'll paste it over here, and I'll modify this command so you will see exactly what needs to be done as compared to x86 machines. I'm gonna delete GPUs all over here, right? So all this will be gone, and instead we will do minus runtime space and NVIDIA, right? And that is it. So let's hit enter over here. It is pulling all the Docker images, all the Docker related stuff over here for us. And in a few seconds, it will be ready. I think for Llama 3.2 3 billion parameter model, we should expect around 20 tokens per second on this device, given that it has about 1000 CUDA cores. So we'll see if it is actually using the runtime of NVIDIA, then we will see about 20 tokens per second. And the moment of truth is here now. So let's see. Docker PS. So we have Ollama running, which is nice. And let's do Docker stat. Yep, Ollama is running, so that is good. So now what we have to do is Docker. So we have to go inside the Docker and run a command. Llama run Llama 3.2 3 billion parameter model, and we will do verbose so we can see actually what is going on over there. So at this point of time, it is pulling Llama 3.2 image, and verbose will show you how many tokens per second we are getting from this particular model over here. So this is the reason you see 115 megabytes per second we are getting. It is pulling at full Gbps speed approximately over here, and that's why I had hardwired this thing. All right, so you'll see that the about 2 gigabytes of file has been pulled now, and it is asking us to type a message over here. So let's do a hello and see what it does. It says 13 tokens per second, which is very less. We'll ask it to tell us a short story about 5 lines long. Let's just ask it this. Okay, so printing its output looks decent. Let's find out how many tokens per second it is. So 14 tokens per second, which is still lower than what I would have thought. I'm pretty sure that we are at a lower power mode right now. So an easy way to check this is by getting out of it. So let me come over here, buy. Oops, no. All right, bye. Okay, and what we can do is there's a command called NVP model, and you can do a -q on it, and it will show you exactly what the power mode it is right now. The power mode is 15 watts of code. So for 15 watts, 15 tokens per second is fine. This is actually not bad. I mean, 15 tokens per second is okay over here for 15 watts. But I think if we want, you know, the max N performance, then we'll have to switch it to the max N mode over here too. All right, so that brings us to the NVP model over here, right? So we have this NVP model, if I can write over here, and then NVP model has two main commands that we'll be taking a look at. -q is to query using the terminal the mode that we are currently on, and you can also use verbose over here with it, or -m that will let you set the current power mode that you want. But how do you even know? So -m takes a integer number after this, right? So like 0, 1 or 2 or whatever. So how do you even know which particular power mode you want to set? So this is actually in /etc/nvpmodel.conf file, which is what we'll take a look at right now. Okay, so we've already seen the NVP model. So let's do that again. Sudo NVP model and -q shows you the current power mode. If you do verbose over here, you will see it spits out a lot of information over here, right? Now, let's say if you want to see what all different power modes are available. So you will see that this particular power mode is 0. Right, so even though it is 15 watt power, but it is the power mode of 0. This is what it was showing you, and that's on the top. It is saying the number 0 over here. Now, what all different power modes exist? So the way to do that is you will do so you can do a cat on /etc/nvpmodel.conf over here. So this is the file that has all the different power modes and everything. So you will see this is a huge file, right? It has tons of different information over here. So parameter definitions and all that, you can skip that top part. However, if you come down, it says power model definitions, right? So the power model ID 0 corresponds to 15 watt. If you scroll down, ID 1 corresponds to 7 watt. And if you scroll down, ID2 corresponds to max N power mode. And this is the power mode that we want. So we have to just use our command correctly to set to the power mode of 2. So which is sudo NVP model, right? And we'll do -m over here and the power mode of 2. And this is what sets the power mode to 2. So now if you do a query again on this, you will see it is set to max N and the power mode of 2 is set over here. And the beauty of this command is that it persists with the reboots too. So even if you have rebooted the machine, you will see this max N performance mode over here. Okay, right? We'll run this again and we will see if we see the performance increase from 14 tokens per second to 20 tokens per second or not. So tell me a story 5 sentences long, right? And let's see. Now you can see that the output tokens are really faster as compared to previous. So 21.79 tokens. This is the performance that we want to see. This is awesome. So evaluation rate 21.79, perfect. Now we can say bye to the model and model will be very happy over here. So the next step in our process is to move to OpenWebUI setup over here for us. So to install OpenWebUI, we need to go to our AI server setup guide again and just scroll down all the way to OpenWebUI installation in the Ollama and OpenWebUI installation setup over here. And at the very bottom, you see this command. No changes are needed over here for this command. Just copy and paste and run. The things to notice over here is that you are having the port of 3000 exposed over here. And you're also having your volume mapping done. and the name of this particular container is OpenWebUI. You have the restart always flag on, which means that your Docker container will come back up with the Docker service, and it is going to pull from the OpenWebUI's main repo over here. So let's hit enter. Let's have this download and run. And this image is pretty big, so it is about gigabyte of image, I believe. All right, so OpenWebUI is done, and now we can easily go to our any web browser and just open OpenWebUI. So let's open Edge over here, and on the Edge, let's open Jetson Colon 3000, and let's open our OpenWebUI. It'll take a few seconds. While the OpenWebUI actually also, let me do this, Docker PS, and both OpenWebUI and Ollama, they both are up, which is nice. And let's see, perfect. So let's do get started. The very first account is very important, so make sure that you create your account and you do not forget, because this is your admin account on OpenWebUI. So just make sure you're doing that and hit create admin account, and you are in now, right? So 53053. So this was released a couple days back over here on the 31st. Let's go. And you will see you already have Llama 3.2 available over here. And you know, while we are talking, let's also download Quen 2.5 coder colon 7b, I think, right? Or 8b, I think it's 7b, I'm pretty sure. Let's download this model, and this would be a good model to test, because I believe it will take about 4.5 gigs of whatever we call VRAM, right? In general, in GPU's terminology. So it will take 4.5 gigs of VRAM over here for us, and it should fit on the on Jetson. It should fit very easily. So we'll download that. While it is downloading, we'll just do a quick test with our OpenWebUI. Let's choose Llama 3.2 3 billion parameter, and let's just take this default prompt. Let's send it, and you will see the model already starts talking to you in a very nice ChatGPT kind of format over here, which is great. Now you have a web interface, and you also have a model running in the background. So while this model is generating, let's wait for a few more seconds so we can see the token generation over here. You can see 20.91 tokens per second. That's the very top thing that was listed over there. And you will also switch to a medium, kind of lower medium size model, Quen 2.5 coder 7b, and let's regenerate the same prompt over here, like the same response over here, and let's see how much time and how much tokens per second does Quen take as compared to our previous model, Llama 3.2 3 billion parameter, right? So this appears to be about 6 tokens per second to me. It's about 3 to 4 times slower than 3 billion parameter model, which is not bad. You know, it is readable kind of speed over here. And this reminds me of GPT-4 time, right? When we had GPT-4, this is the speed of that. So it is not bad. 7 billion parameter model running on the palm of your hand almost, right? So the speed is not bad. It's not ideal also. If you compare with 3 billion parameter model, you definitely see it lagging. Let's see the speed over here. It is 7 tokens per second, 7.1 tokens per second, which is pretty awesome. All right, so we have our Ollama setup, and we also have our OpenWebUI setup over here. So this is exactly what we wanted to do in this video. So we have a basic, setup for our AI server going over here for us. So on the palm of our hand, we have Jetson Nano, which has Jetpack 6.1 installed, which is the Ubuntu 22.04, essentially ARM based, and we have it installed on SSD, which is also nice, so we don't have to be reliant on the unreliable SD cards anymore. We have Docker set up correctly, so it doesn't use the sudo permissions, and it runs directly with your user. And we have Ollama running in Docker and using the runtime of NVIDIA, and we have OpenWebUI running also over here. That gives you a nice web interface. So that gives you a full ChatGPT kind of, environment over here. All right, that is all that I had for this video today. Thank you everyone for watching, and I'll see you guys in the next one.